Alrighty, so our new section is about inverse functions. So like I said, we're going to see a lot of old stuff showing up again. We're still going to be using function composition. And the problem that a while back that I said, hey, these both go down to being x. That's important. That's going to come back later. Well, now is later. So those functions were really important because those were what are actually inverse functions for each other. There we go. All right, so the actual definition for inverse functions looks really, really notational and heavy, but it's not as bad as what you'd think. So it looks worse than what it's really saying. So we've got functions f and function g. So those are just two normal functions where f of g of x equals x. And g of f of x also equals x. And we have a little caveat there for every x in the domain. So it doesn't have to equal x if it makes it undefined at some point. But if you can take g and substitute it into f, simplify it down to being x, and you can take f and substitute it into g, simplify that down to being x, then those two functions are inverses of each other. So usually what we do at that point, rather than saying g of x, we change that to f inverse. So that's what that f looks like a -1 exponent is. That's right, f inverse. So if you do have two inverse functions of each other, your domain from the first function is equal to the range of its inverse, and the range of the first function is the domain of the inverse. So the important thing to note here is that f of g of x is x, and so is g of f of x.
So would g of f of x be the negative?
Yeah, that's where we would say like f inverse of f of x, or here we would say f of f inverse of x. Yeah, you could replace that g with the f inverse function. So we usually start out by calling it g just because until you actually show this, you don't know that they're in the inverses of each other.
So confusing.
Yeah, it was confusing. I'm confused.
But if you're gonna go on hanging out.
See, this right here, that's why I'm so glad I'm like high school. Oh goodness.
What do you say?
Because he tries to pretend like he doesn't read my phone.
He didn't say it. Dude, if I found out.
No, because he knows I get mad at him for reading my phone, so he's not gonna say anything.
Well, wouldn't he even be upset?
Oh, shoot.
Sounds like a great relationship built on mutual trust right there.
No.
Cycle's a big word.
You said it's not a good relationship.
This is a relationship. I just don't like that he reads my phone. Like, he shouldn't have to read my phone. Just
Goodness. All right. So basically, how do we check to see if they are actually inverses? If this holds true, then they're inverses. So a lot of times what you're going to be asked to do is determine whether or not two functions are inverses of each other. So you have to check f of g of x and g of f of x. Because it's possible, unlikely, but possible that one of these will simplify down to being x and the other one won't. So that doesn't happen very often, but it is possible. So you have to show both of them simplify to being x. So that's the easiest, most straightforward way of determining whether or not they're actually inverses. So if you get anything other than x, even like a 2x, they're not. Yes. Sure. All right, so here we've got two functions, and we're going to determine whether or not they're inverses of each other. So we've got f of x, which equals 4x, and g of x, which equals x over 4. So we'll start by looking at f of g of x. So we're going to take that x over 4. Oh, goodness. And substitute that in there for x. Thank you. So we'll have 4 times x over 4.
Isn't it just gonna be x?
Yeah, because those are being multiplied, our 4's would cancel. And that's just x. So, all right, f of g of x works out nicely. G of f of x. Well, we're going to take that 4 over x, substitute it into the top of our fraction. And we get 4x over 4. Well, yeah, those 4's will cancel. So we get x. Are these inverses of each other? Yes. All right, so let's talk for a second about work. What kind of work do I expect to see on these? I want to see which one's which. If you don't put the x, I'll get over it, but I want to see f of g and g of f. I need to see it substituted in, and don't just equals x. I want to see the individual steps that lead you to whatever your conclusion is. So if, well, we'll look at some later that get a little bit more complicated because this one's like about as easy as they get. If it should have 3 steps and you just say equals x, that doesn't count. So I need you to show me the individual steps that you'll take along the way here. Let's look at one that's a little bit more interesting. So we've got f of x equals 5x minus 9, and g of x equals x plus 5 over 9. Yes?
You said the answer will always be x.
If they're inverses of each other, yes. If you get anything other than x, that means they're not inverses.
So if
Alright.
like the first one doesn't equal x, you can just stop there.
Correct, because they both have to work.
Okay.
All right, so we're going to take that lovely fraction and substitute it right back in there for x. So let's see, we'll have 5 being multiplied by x plus 5 over 9 minus 9.
You can distribute the five.
Right, we would distribute the 5. So we'll get 5x plus 25 over 9 minus 9. Okay, now what do we need to do to combine those?
Oh, you only do it to the top?
Yeah, if you do it to the top and the bottom, you're not really doing anything.
Okay.
Because you'd be distributing 5 over 5.
Okay.
So what would we need to do to combine these two?
You should have a common
Let's say with a little more conviction. Yeah,
I have a common denominator.
exactly. We would use common denominator. So what would our least common denominator be here? 9. So this 9, if we multiply by 9 over 9, it's really 81 over 9. So if we subtract 81 from 25, alright, let me fix this. I think it's 56. My mental math skills are working today. Over 9. Can we do anything to simplify this further? No.
So this is not, these are not inverse.
Yeah, these two are not inverses of each other. Yeah, if it doesn't work for one of those combinations, there's no point in trying to check the second. Because even if it did work for the second, they're still not inverses of each other, so we might as well just stop.
No, they have to equal x, or they have to equal the same number.
X.
Okay.
That'd be interesting if they equaled something other than x. But yeah, not inverses. Yes.
How'd you get the 56?
25 minus 81. Because that 9 is really 81 over 9. Anything else with this guy? Alright. Another pair here. So this time we've got f of x equals 3 over x minus 4, and g of x equals 3 over x plus 4. Alright, so we'll start by looking at f of g of x again. So we're going to take the 3 over x plus 4 and substitute it into the bottom of our fraction here. So instead of x, we'll have 3 over x plus 4, and we've got a minus 4 after that.
So instead of showing, can you just cancel those out by showing it?
No.
Okay, so you have to.
That's what I'm talking about. I want to see it in receipt. I want to see it substituted in, and like here, we would cancel out those 4s. So we've got 3 over x.
We usually multiply by x. Or 3 over.
We-
I'm confused.
Oh, wait, no,
You
no,
can
no, you
multiply
were
it
multiplying by
x
x
by
over
x,
3.
and there'd be 3x on top and then just 3 on the bottom. And then
We could multiply by x over x, or what else?
X over
Multiply
3.
Right, or we can multiply by the reciprocal since we're just dividing by a fraction here. Either way, you'll get the same answer. So if we go the reciprocal route, you take 3 and multiply by the reciprocal of the denominator, which would be x over 3. And now those 3's cancel. And we get x, so we have hope.
There's 3 one of those ones where you do all this work just to find out that it's not.
Perhaps, we'll see. Alright, so now we're going to take our larger fraction here and substitute it into the denominator of our smaller one. So we'll look at g of f of x. So we would have 3 over x minus 4, then plus 4 after that. Alright, so again we're dividing by fractions, so multiplying by the reciprocal would be appropriate here. So we've got 3 being multiplied by x minus 4 over 3. So those 3's would cancel, which means we've got x minus 4 plus 4. And now those 4's will cancel, and there's our x. So are these two inverses of each other?
Yes.
Yes. Indeed it does.
Can we combine stuff to like
Nope.
show this?
So that's what I was talking about earlier. I don't want to see 3, 3, 4, 4, x. I want to see individual steps. If you don't show me the individual steps, you're going to be getting back.
That's more than what you usually want.
I know. But that's because honestly with these, it's really easy to get into a canceling frenzy and end up with x when you shouldn't. So it's really for your own good.
Minus 81.
So anything else with this pair?
Because she multiplied it by 9.
Alright, how are we feeling so far about testing to see if two functions are inverses? Anyone?
No, wait, now I'm not one.
2's,
Zero.
4's, 5's.
I don't know which way I'm like 25. I'm like anywhere like this place. I'm like,
And so like these two
No,
ones
that's-
must be equal to either one.
yes.
Alright, so now the next thing we're gonna look at, now that we know how to test if two things are functions,
Okay.
we're gonna see how do we actually find the inverse of the function. So how do we find it? So it's really handy if somebody hands it to us and we're pretty sure that it's the inverse and we can test it and yay, it works. But if we're actually supposed to find the inverse ourselves, first thing we do is replace f of x with y. And then the next thing we do is we interchange our x and our y. So wherever you see a y, you switch it to being an x. Wherever you see an x, you switch it to being y.
Wait, so would you change the y that you just put in there into an x?
Yes.
What's the point of putting it as a y? You just,
Because remember, f of x is just a different way of saying y. So we're starting out by replacing it with that other notation.
Okay.
So then what we do is we take that new equation after we've switched our x's and our y's, and we solve that equation for y. And when you get it to be y equals stuff without y, that is your inverse function. So then we replace that y with f inverse of x. So we do have to be pretty careful with all the notation here because we are going to be switching things around quite a bit.